Happy Thursday. What's the agenda today? Finish up area between curves, and then we'll just look at trigonometric integrants. Strategies for evaluating them. Region between x cubed minus 6x squared plus 8x and the x-axis. What do we want?
I think it's 6x squared. Do you want the 6x squared?
Yeah, I read that as an 8 instead of a 6. Actually need this, but that's actually pretty good. So what's the region? Well, it's 1 over all region, but we can split it into 2, yes. That's the area we're trying to find. Keep in mind, we want area, not signed area. actually two ways to set this up. Since it's since it's bounded by the x-axis on the curve. First way is to recognize this as two separate regions. Find the area of each region, add them together. Which is the same as setting it up this way. Integrating the absolute value of the function. What are we integrating over?
0 to 4.
We'll put this back up. Oops, not 0 to 4. Obviously splits at 2. From 0 to 2, the area is positive, isn't it? And then from 2 to 4, the area is negative. So it would actually be 0 minus the function of what we're integrating. It should be the same effect as just doing this. Because that first integral is going to give us a positive area, which is fine. That second integral gives us a negative area. So if we do minus a negative, it's the same as adding it. I could also use symmetry here and say that those two areas are equal. So it's really just twice the first area. Now, but let's say we're not 100% confident that it's symmetric. That would be safe than sorry. Antiderivative for the function.
Minus 2x to the third. Minus or plus 4x squared.
Well, the second integral is the same integrand. So same antiderivative. Which is why writing it as a minus instead of plus, negative of everything inside, is more convenient. What is 2 to the 4th? Over 4. What is 2 cubed times 2? What is 2 squared times 4? What's 4 to the 4th? 256. What is 2 to the 4th? What's 256 minus 16 over 4? 4 cubed minus 2 cubed. Times 2. 4 squared. 2 squared. 16 minus 4 times 4. That makes me happy. 0. 4 and 112 is 116. What is 60 and 48? I'm ignoring the negative. 108. And then 116 minus 108. And there's the area. 8. Congratulations, you just did arithmetic in your head. See, it's not that hard. And it was quicker than typing into a calculator. This one's cool. Plot the curve y squared equals x squared minus x to the 4th. Find the total area enclosed by the curve. I know, prior knowledge is a terrible thing. I already know that's the best view on the window. Actually, I'd probably do better, but that's convenient. Let's turn that frame off, turn the axes on. That's the curve. Brownie points if you know what that curve is called.
Butterfly curve. Hourglass curve.
called a lemniscate.
That was close.
Which one was close to lemniscate?
That was close. That was close.
That's the area we're trying to find. Then you could recognize you have two regions. Find the area of both. Add them together. But wait a minute. That's symmetric. Which means those two regions have the same area. So find that region and double it. But it's also symmetric about the x-axis. So if we just find that yellow area and then quadruple it, we found the total area. That is the route that I'm going to take. First, what are the limits of integration? Zero to one. And very easy to find. Just set y equal to 0 and solve for x. You get three values, -1, 0, +1. We clearly want 0 to 1. What's the integrand? So what is the function that we want to integrate? Sure?
Absolutely.
Why?
Because we have to solve for y.
Okay, what happens when you solve for y? If you're saying that's the solution for y, that is incorrect.
So I know technically it would probably be plus or minus, but we want the positive one for this example, right?
The solution would be plus or minus. We want positive. Why?
Well, the section of the curve we're using is above the x-axis, and it is moving in a positive
Don't worry about the direction of the curve.
Alright.
That's Calc 3.
Alright.
It's just the curve lies above the x-axis, which means all of your y values are positive. Oh, not positive, non-negative.
Alright.
How do you want to integrate that? No calculator allowed. How does that help you? Can you? That'd be if it's square root of x. This isn't square root of x.
Absolute value number.
How would that help you?
Make it positive.
It's already positive. Actually, I forgot something. Forgotten quadrupling this.
Would it help to redefine, no, not redefine, would it help to find a new variable, say u, and find that as x squared, so we rewrite this as the square root of u minus u squared, would that help us?
If you do that, what's du?
Well, not very helpful. That's, well, it's 2x.
Which we don't have an x.
We have to put du in.
Yes. If you do a change of variable, you also have to change your differential.
Alright.
You are overlooking it. It is obvious.
Hey, can we just do difference of squares?
You could, but that's not going to help in this case.
Okay.
You can factor out an x squared, can't you? What's the square root of x squared? Technically, no. What is it? Absolute value of x. But what is our interval? Which means x is always positive on that interval, so you can drop the absolute value. Ah. How would you evaluate that?
Now, can't you do use substitution?
What's u?
1, say, 1 minus x squared,
What's du?
2x,
What was it?
or
What is it? Negative 2x. Oh, I have a 2x. Don't have the negative. What are the new limits of integration? When x is 0, what is u? When x is 1, what is u? 1 to 0. Now distribute the negative to flip the order. And I'll write even 1/2. What is that antiderivative? What's 1 to the 3 halves? What's 0 to the 3 halves? 1 minus 0. 2 times 2/3. There's your total area. You might revisit this in Calc 2. Because you can parameterize that.
What?
Parameterize it. Right as a parametric curve. And then there's an area formula using parameterizations, which is generally easier than this. Questions on area between curves?
I have a question with this problem specifically. In my mind, initially when we had our x factored out of the square root there, my initial thought was to take that square root, stick it in some parentheses, and put that on the bottom of a fraction under 1, then put a -1 on the outside. So still technically not changing the value, but then we have a setup for the derivative of arc sine or something.
You do not in that case.
So we do not.
Because that square root's being raised to the -1. You'd have square root of 1 minus x. It'd have to be 1 over the square root of 1 minus x squared to be the inverse sign.
Okay, so
Not 1 over that square root raised to a -1 power.
Okay,